Hello, welcome back. Now let's explore exception level 3. That is the highest exception level in Armv8-A architecture. So exception level 3 is highest privilege level. So it has the full control over all of the hardware resources, such as any of the assembly instruction or any of the register or memory address. So here, what you can see is architecture diagram that specifies how each of the stack is running at each exception level. So as you can see, at exception level 3, the secure monitor runs. The exception level 3 is initial exception level. That means if you give the power to the system, the initial exception level is exception level 3. Now, here is the boot sequence diagram that describes how your system can be booting up. The system, the critical initialization can be configured, can be done at exception level 3. That is performed during the boot time. For this reason, the bootloader or the bootloader can be running at exception level 3. For more information about the boot sequence diagram, I want you to refer to another session of the lecture. So after this initialization job is done, the exception level 3 can be used as gatekeeper between non-secure world and secure world. So please look at this. At exception level 3, secure monitor runs. Take for example, if the SMC instruction is performed in the non-secure world at exception level 1, the exception level switch from EL1 to EL3. Then after, it move the controller to the exception level 3, then software can enter the trust corner in the secure world. And the SMC, the secure monitor call instruction, can be executed in the secure world. So after this assembly instruction, it moves the controller to the exception level 3, and then it will move back to the exception level 1 in the non-secure world. Now let's look at another architecture diagram based on the virtualization system. As you can see, there are more than 2 operating systems in virtualization environment. Here, this is the first guest OS. Now, it is the second guest OS. So, SMC assembly instructions can be used to transit from the non-secure world and secure world. But in this case, the Linux kernel at exception level 1 in each guest OS can perform SMC assembly instruction. And just like this architecture diagram, it moves the controller to exception level 3 from exception level 1, and then it will enter the secure world. And then the securely sensitive application finishes its operation. The SMC assembly instruction can be executed in the non-secure world, and then they move the controller to exception level 3. Then it will go back to the non-secure world. In summary, the exception level 3 can be acting like a gatekeeper between 2 execution worlds. Now let's outline the important point of exception level 3. The exception level 3 is corresponding to the privilege level 3. That is highest the privilege level in Armv8-A architecture. For this reason, it has full control over all of the hardware resources in the system. It can write any data onto any of the system register, so it can run any of the assembly instruction for system configuration. So for this reason, chipset maker configure initial exception level as exception level 3. Once initialization job is done at exception level 3 during boot sequence, then EL3 is used as the gatekeeper between the 2 software worlds. That is the non-secure world and secure world.